Okay, cool. Hi, I'm Meghan Yap-Chiongco. I am a PhD candidate at the University of Alabama in Dr. Kevin Kosat's lab. And I had the opportunity to kind of do like a side master's project while I was doing my PhD. So I'm still in my PhD, but this is my work for my master's. And so this is on adding small taxa to fill big gaps, a phylogenomic analysis of Solenogastres, including data from meiofaunal species. Let's see. Okay. So first off, I wanted to give a little background and talk about what an aplacophoran is. So aplacopherans are mollusks, which are, you have your kind of more recognizable mollusks like your snails or bivalves or cephalopods. But in the COSAT lab, we study kind of the lesser known mollusks or the lesser appreciated mollusks, I like to think them as. And they're in this clade here called Aplacophora. And specifically, I work with aplacopherans. And these animals lack a shell. And instead are covered in these calcareous spines and spicules that are called sclerites. And for the purposes of today, I'm going to be talking about one of the two major groups, the Solenogastres. And the difference between the two major groups of aplacopherans is that these caudophobeids actually lack a foot. And the Solenogastres do have that like molluscan foot, except it is reduced to a pedal groove. So there are about 291 a species of Solenogasters. So again, they do have that reduced foot. You can kind of see it just in this line of the ventral side of the animal here. And they use that to glide across substrate, or sometimes they're found on cnidarians that they eat. So there's a big epimenia here that is found in association with some of these corals. However, today I'm talking about some of the meiofaunal animals, and meiofauna is more of a functional definition, and that is animals that can pass through a 1 millimeter sieve. And by this kind of functional definition, in the meiofaunal kind of taxonomy book that came out last year, Franzi Bergmeier and Katharina Jorger categorized about 23 species of aplacopherans to be meiofaunal. And in Solenogasters in specific. However, because of their worm-like body plan, they can kind of twist and make their way through that sieve. So what truly meiofaunal is in Solenogasters is kind of hard to pin down, because these animals can be anywhere between less than half of a millimeter to, in the giant epimenia, around 30 centimeters. So body size in aplacopherans tends to be a little bit smaller. And so it's hard to kind of determine where the smallest of the small starts. Within 23 of those meiofaunal species, at least 10 are described from the interstitial habitat, or living in between the sand grains. So now to get into some of the taxonomy. So characteristics for Solenogaster taxonomy, they are really morphologically uniform. So there's only a few things that we generally use. Those calcium carbonate scales, spines, and spicules called sclerites. They do have a radula. We use for Solenogasters, we use how many teeth per row. So one tooth per row would be monostichus. Some of those are here. Distichus, 2 teeth per row, and then polystichus, or many teeth per row. And then we also use characteristics of the microanatomy of the foregut glands in these animals. And based on these characteristics and the thickness of the cuticle, Solenogasters are separated into 4 major groups: the Neomediamorpha, the Pholidoskepia, the Stereofustia, and the Cavibelonia. And these are just some words that I kind of like to associate with them because they help me kind of remind which animals are which. And if we're talking about the breakdown for where these meiofaunal species exist, as you can see here, they're mainly concentrated in this Pholidoskepia group, or the ones that in my head I call small and scaly, because they're covered in these kind of more leaf-like and flat sclerites. You then have the Neomediamorpha, which only has one species, and these are kind of more small and squat, so they can be quite thick, and they have these kind of harpoon sclerites. And then you have Cavibelonia and Stereofusia, which have these kind of needle-like sclerites or these little pin-like sclerites. And the major difference here is that they're both spiny, but the sclerites within Cavibelonia are actually hollow. And the Cavibelonian species generally represent some of the largest species that we know. So to get into some of the historical cladistics of this, this was a paper in 2003 by Salvini-Plowin, and it was the first kind of family level look using phylogenies rather than like a character-based phylogeny of the major families and groups of Solenogasters. And as you can see here, it's not a really great resolved tree. It was based on 53 characters. However, it did kind of confirm this original thought on Aplacophora evolution, that the ancestor to all other Solenogasters were something that was small-bodied, Pholidoskepia-like with scale-like sclerites. However, in 2019, Kosset et al. Published this paper, which looked at the first transcriptomic-based approach to look at higher-level Solenogaster relationships. Aplacophorans in general, but for our purposes today, we're just looking at this part of the tree. And it kind of went against what traditional thoughts were on Solenogaster evolution, because they recovered this Amphimenidae clade at the base, which are these large-bodied Cavibelonians. And as you can see here, the kind of four-order scheme didn't really work out because these were recovering as polyphyletic groups. And so as a part of my master's work, I was doing a barcoding project to look at the diversity of meiofaunal Solenogasters. And this tree looked at included one of a very important family, Myomenidae. It is the only family within Solenogasters that is fully interstitial and fully meiofaunal in size. So it's important to help kind of contextualize body size evolution within Solenogastries. However, when I started doing this work, we started seeing that there are two different species of the type locality of this Myomenius fedmarchi, where Kevin had collected this animal for this transcriptome. So we were like, let's make sure that this is what it is. And it turns out it wasn't, that the animal included in this analysis was actually a different species and not actually Myomenius fedmarchi. So this transcriptome tree actually lacked any representation from the family as a whole. And so we wanted to for the second kind of part of my master's was to look if we start increasing our taxon sampling of this transcriptome-based tree to include interstitial and meiofaunal species, is that going to change how we think about higher level relationships within Solenogastries? And in order to do this, we supplemented that paper, those analyses, with 8 new transcriptomes of meiofaunal and interstitial lineages of Aplacophorans. We assembled those transcriptomes with Trinity, and we translated them to peptides with transdecoder. And then we used OrthoFinder for orthology inference and a program called PhyloPypruner to refine those orthogroups just to make sure that we were comparing apples to apples. And based on the refined group of orthologs, we had 1,439 genes with a total of 35,980 amino acid positions, with only about 34% missing data from our original ortholog set. And we constructed a maximum likelihood tree on that super matrix using the best fitting model and 1,000 rapid bootstraps in IQ Tree 2. And so now to go through some of the results, I'm going to zoom in and give kind of like a brief rundown of all the parts of the tree. But just right off the bat, we can see that this Cavibelonia clade, those hollow, spiny, big animals, are still non-monophyletic. With the Kosset et al. Tree. Different from that tree, though, is with the addition of some of these bolded animals are the ones that we added. We now see that this Pholidoskepia group, which was monophyletic in their tree, is actually coming out as polyphyletic.
You've got 5 minutes.
Thank you. So the family Pronomenidae within this tree here is non-monophyletic, and we did see this in the 2019 tree. This was another species that was misidentified in that tree, and so we can say that this family is non-monophyletic, and that's backed on morphological data that is unpublished from our postdoc in our lab, Carmen Cobo. One of the important interstitial families, Lepidopteridae, here is not recovering within Pholidoskepia, even though they're small and scaly. But we do have a weird instance of this Lepidopteridae species from Hawaii that looks like a Cavibelonia with those like hollow needle sclerites. So this is something that's very interesting. And this is based on microanatomy and also by pulling out 16S and CO1 and comparing them to other Lepidopteridae species. Next, this Pholidoskepia spa species from Washington. This was the old Myomenius fedmarki in the 2019 tree that turned out to not be. And it is recovering with this family Gymnomeniidae. And these are the sclerate morphology of that animal. So, and two of the genera within this family. And you do see some superficial similarities between these kind of like leaf-like ones. And this very characteristic keel within Virenia here, you can see that some of these more, these sharper sclerites actually have one of those keels. So this relationship should be investigated further. This is just to briefly show that the placement of that Amphimediidae family is still in the same position, but it is no longer the sister to all other Solenogasters. And we are recovering, like in that early cladistic analysis, that this Dondurzidae family is non-monophyletic. And it is interesting to note that here at the base is this Dondurzia tati animal, which is kind of it was identified in the field as in the family Myomeniidae, that fully interstitial family, but it is definitely not a Myomeniidae based on histology, but it's not quite a Dondurzia like it was put in based on the morphology either. So it's kind of this weird animal that we don't really know much about. And the alternative text on this animal, it says a loaf of bread if you put it up, but the species identification software is not really there yet because it, thinks this is a loaf of bread. And finally, at the base of the tree, we're seeing these myomeniids and these small-bodied animals as sister to all their solenogasters. So here's all those myomeniids, and we checked them based on barcodes with all of the other barcodes that we have from Friday Harbor and Bermuda and all these other places. And we checked our transcriptomes by pulling out 16S and CO1, and they are recovering within this Myomeniidae clade. So we actually have Myomeniidae in the tree now, and it is sister to all other solenogasters. And then this clade at the beginning, we have this interesting species from Florida and that weird Dondurzia creature. And it is interesting to note that the radular morphology of both of these animals are different. This is a distichous radula, and Dondurzia tati was described with a monostichous radula. And you saw that this is relatively long branch, so we were worried about long branch attraction. However, the program Phylopypruner interprets contamination that could lead to long branches as parology, and as you see here, the rates of parology are nothing for those two species. We also ran another analysis using the site heterogeneous model, which is known to combat long branch attraction. And we did recover the same topology of the tree with just slightly less support, but that is good evidence that this is a real relationship and just not grouped together because of high rates of sequence evolution. And so finally, these implications for evolution, we're starting to revisit earlier ideas in Solenogaster evolution, where people were discussing that, the first mollusks might be small animals, which we know now were, something more of a chitin-like ancestor was the ancestor of Aplacophora. However, those are still evidence that Solenogasters evolved from a small-like ancestor. So we have a small-bodied ancestor with these scale-like sclerites, and we would like to look further into radular morphology and foregut gland evolution, but we need to do that with a full ancestral state reconstruction. And with that, I would like to thank you for your time, and I'd be happy to answer any questions.